So we're going to talk about the find method in binary search tree as well as the dunder contains method. So we said at the beginning, one of the reasons that we want to implement BST is so that we can do kind of binary search, lookup of information because we know that's fast. So here we're going to write the find method for binary search tree. Now, you might really kind of maybe consider trying to write that yourself because it's very similar to a lot of the operations that we've done. So anyway, I am going to do this just slightly differently from the other operations that I've done because I know what this week's assignment is about, and I like to kind of prepare for that. So the only twist that I really have here is I want to be able to, given a piece of data, I want to be able to find if that data is in the tree. And also, I want to not just find the data, I want a different method that will find the node that contains the data. Okay, so I've already written the code here. So the public version of find data, the version that the client would use is it's going to use the private version that finds the node. And once it finds the node that contains the data, it would just return the data in that node. So that's just an extra level of interaction on top of it. So that's really the only difference from the everything else. And now as for the find node, there's still this, I guess it's no longer a public version, but let's call this the non-recursive version that finds the node that contains the data. And then there will be a recursive version of find node that would find the node that contains the data in a particular subtree. And as with other operations, here are the couple of base cases that, okay, first of all, if the subtree root, if the root is empty, if it's not there, then we didn't find the data, right? And the next kind of base case is if the data, if the root is the data we're looking for, then yeah, we find the node that contains the data. So we return the node or return the root. So yeah, that's what these two slides are trying to say here. So the next thing is, okay, the recursive case, and it's really kind of what you would expect. And it's so if the data is smaller, if the data we're looking for is smaller than the data at the root, then we kind of return the recursive version. We're going to recurse down the subroots, well, left child, not right child. Okay. Otherwise, then the data is bigger, and we're going to recurse down the right child. And oh, obviously, I forgot to put the data here. Let's put it here. Data. Okay. Now that we have an implementation for find, we really should test it. And I've already kind of written out one test case. So that's just test find. And here again, I set up a small tree. I insert, I insert all the data from the list. And then I try to find every single one of them. And then, yeah, what I find should be exactly what I'm looking for. So let me run this. And there we go. That's good. Now, also, I should make sure that if I'm looking for something but it's not in a tree, then it should raise the not found error. And that's what I do here. So the first thing I do is in an empty tree, I just trying to look up anything. It should raise the not found error. And if I set up a tree with some data, but I look up a data that's not in there, it should also raise the not found exception. So let me do that in my test passed. That's good. Just like in linked list, the find and the dunder contains kind of go hand in hand. And remember what dunder contain does is if the data does exist in the data structure, then it returns true, otherwise it returns false. And now that we have the find, it should be fairly straightforward to implement that. So please go ahead and give that a try.